Hi, my name is Margret. In this video I'm going to introduce you to autoboxing and unboxing. Autoboxing is the automatic conversion that the Java compiler makes between a primitive type and its corresponding object wrapper class. Let's look at an example. Let's say we have an integer n1 and we assign the value 7. n1 is of type int, which is a value type. All primitive types in Java are value types, and the value is stored directly in the variable. Now I'm going to add a second statement. I'm declaring a variable n2 of type uppercase integer and assigning n1. Notice n2 is a reference type variable, so here is no value but a reference pointing to the object on the heap, and the object on the heap includes the value 7. This process of converting a value type to a reference type is called boxing. It is performed automatically by the Java compiler. The compiler translates n1 to integer dot value of n1. The Java compiler calls the method value of, static method of type integer, passes n1 as an argument, and thus receives the boxed object as a return value. Now I want to talk a bit about when autoboxing occurs. The Java compiler applies autoboxing in two situations. A, when the primitive value is passed as a parameter to a method that expects the corresponding wrapper class. B, when a primitive value is assigned to a variable of the corresponding wrapper class. Once again, let's look at some examples. First, an example of a value passed as a parameter. Here I have a variable called numbers. It is declared as a list of integers. Notice, uppercase integer. We initialize it with a new array list, which is still empty at this point. And now we want to add some values. So I say numbers add 13. 13, of course, is an int literal. And my list is a list of uppercase integers. Not a problem, because the Java compiler is going to perform the conversion for us. It's going to turn the int 13 to an uppercase integer 13. So here is a second example. We have a variable number of type integer, and we want to assign a value, let's say 13. Once again, 13 is an int literal, and my number is of type uppercase integer. The Java compiler performs the conversion for us. It does the autoboxing that changes 13 of type int to 13 of the reference type uppercase integer. Unboxing is the reverse process of boxing. It converts an instance of a wrapper class to its corresponding primitive type. Let's look at an example. We have a variable num1 of type uppercase integer. That's the reference type. So here you can see num1, and the variable has a reference to an object on a heap. In my object on a heap, I have the number 17. I have the number 17 because I was assigning 17, and we know that already from before that the int literal 17 was automatically converted to an uppercase integer object that contains 17. I'm going to add a second statement here. I'm creating a second variable num2. This one is of type int, primitive type, and I'm assigning num1. So notice num2 is a primitive type, so my value is stored directly in the variable. I stored the value 17 because this was the value of num1, and num1 had a object with the value 17 which was unboxed to a value type 17. Notice the compiler calls int value on the variable num1. Num1, of course, is my reference type. Int value converts the object that includes 17 to a primitive type int. And here I have my primitive type int 17 that can be assigned to my primitive type int number 2. One more example. Here I have a method. It's called SumEven because it sums up all the even numbers. And I'm passing a list of integers. I call my list numbers. And so I'm declaring a variable sum, initialize it with 0. For all my integers n in my list numbers, I make this following check. Here, check whether n is even. It's even when n modulus 2 is 0. And if that is the case, then I add it to my sum. At the end, I return my sum. Notice that modulus and the compound operator plus equals are defined for primitive types like int, but not defined for reference types. However, n is of type uppercase integer. The Java compiler calls int value on n, and int value reads the number of my uppercase integer object n and returns the primitive type int value. You can see this conversion happens twice, here with the modulus operator, here again with the compound assignment operator. At this point, I want to look at the primitive type versus the corresponding wrapper class. Primitive types are always value types. The corresponding wrapper classes are always reference types, so this is the most important difference. Primitive types have a given range, true, false for Boolean, or a certain number range for integers. The corresponding wrapper class has the exact same range, plus null. Once again, an example. Primitive type stored directly in the variable. Corresponding wrapper class wrapped as an object on the heap. At this point, I want to have a closer look at the wrapper classes. So far, we only looked at int and uppercase integer, the corresponding wrapper class to int. Each of the 8 primitive types has a corresponding wrapper class. Notice they're all spelled with the first uppercase letter, like reference types. Also notice there is a extra abstract class number. By the way, I can tell in my UML diagram that is an abstract class because it is printed in italics. Number is the superclass for the 6 number classes byte, short, integer long, float, and double. All of the wrapper classes have the same range as the corresponding primitive type plus null. All wrapper classes are final, which means we can use them, but we cannot derive from them. We cannot use them as a superclass. Now I want to briefly discuss why we use wrapper classes. There are 2 main reasons. One is the useful functionality that is provided by wrapper classes. The other one is the fact that generics can only accept reference types. And since we can't use generics with primitive types, it's very helpful to have a corresponding class that can be used. I'm not going to discuss generics here. This is going to happen in a different video. But I want to show you a few examples of the useful functionality that is provided in wrapper classes. Integer, for example, has a method called parseInt, and it allows me to parse an integer. I could say integer number is integer parseInt, and I'm passing 1, 2, 3, and now I'm printing out my number 1, 2, 3 and the corresponding number value. Let's compile and run, and we can see the string 1, 2, 3 is converted to the number 1, 2, 3. So to make this extra clear, I could also add some quotes before and after, so we can see the first one is actually a string. Let's compile and run again. That makes it nice and clear. It also has constants, for example, a constant called max value. This time I'm just copy pasting the code in here. You can see we have the max integer. I'm providing my value in 2 new lines, and here is my constant max value. It's a static constant that I call on the type. I compile and run, and I can see a little bit more than 2 billion is my max value. If this is hard to read, we could have a comma separator here. Makes it a little easier. So now everybody can see my 2,147,483,647. Now I want to show you some example with the wrapper class character. I could have a character, I call it CH, and I assign it X. The class uppercase character has a whole number of methods that allow us to check whether my character is a specific instance of something. For example, is it a letter, is it a number, is it an uppercase, etc. So here we're checking is letter, is digit, that's the number of course, is uppercase. And I'm going to compile and run. And it tells me X is a letter, yes, it's not a number, it's not an uppercase. Now that we have seen the advantages of wrapper classes, I also want to point out when not to use them. One thing to keep in mind is that wrapper classes are less efficient than primitive types. So as a best practice, keep in mind, when a primitive type can do the job as well as a wrapper class, prefer the primitive type.